All right, let's take a look at number 127. We're going to do our area under the curve. Well, let's take a look. The first thing we want to do is we want to graph it. We put in a 0, we get square root of 2 somewhere up here, and like labeling exactly as square root of 2 there. And then we want to look specifically 1, 2, 3, 4, 5. So we want to look at the area under the curve of that graph from 3 to 5. So we understand exactly what we're talking about. That will be, I'm representing the exact area. In the directions say we want to consider four left-hand rectangles. So we want to make sure we can draw those correctly. The left always starts on the left side of what we're considering. So we're going to start at 3. And if I want 4 rectangles, I'm going to go up. I've got a distance of 2, and I want 4 rectangles, so my delta x is going to be 1/2. So I'm going to go, this is one of my rectangles. Another one. 3 and 4. So there's my 4 rectangles. The area of a rectangle is base times height. My base is 1/2, and my height is right here. And in this case, that would be the square root of 3 squared plus 2. Plus the next one, 1/2 square root of 3.5 squared plus 2. So we can kind of see what's changing when we write it out every time. 1/2, 4 squared plus 2, 1/2, 4.5 squared plus 2. We got it. We got 4 rectangles. We could just plug this into our calculator and get the right answer. Now, our learning point here is we want to be able to express, 4 or 8 or 12 or 100 without having to write it out. So we want to use our sigma notation. So we're going to do our sigma notation. And we want to say the words start and change. And then I look at my original function, and that's what goes in for x. So I started calculating at 3, and I changed by 0.5. You understand that. We get that. So that is what I'm saying goes in here, wherever x is. 3 plus 0.5n squared plus 2. So you can see what's going on. This is what's changing. This is where we need an x value. And that's its pattern. Its linear pattern is 3 plus 0.5n squared. And then we've got the 1/2 in front, representing the width of our rectangles. And then we've got the height of our rectangles. And then we just need to do our indices. 0 is where we want to start for our lefts. And then how many do we need? 0, 1, 2, 3. There's our rectangles. 0 to 3. Then we want to talk about the rights. If it's the rights, we would calculate the area up here. And instead of calculating the 0 rectangle, we would add in the 4th rectangle. So all we change is, instead of calculating from 0 to 3, we calculate from 1 to 4. I hope you've got a good start on estimating area under the curve using rectangles, and then using sigma notation to express the rectangle so that it's easier to calculate than adding up a bunch of numbers.